G'day YouTube, Warbles on a lot here with clip 3 in the atomorph experiment conducted on the Mark III SunFoil. It's almost 11:30. As you can see, the panel has got a slight inclination to the north, and if we come around here, there's the horizon and there's the sun. Alright, we've got blue sky conditions, fellas. There's your charger showing both lights brightly lit, which indicates I am not connected to the battery, but there is sunlight on the panel. As Mr. Turing said, you sure can convey a lot of information with two switches that are either off or on. In the case of that regulator, it's got the ability to have halfway positions as well. It can dim either one of the lights. Okay, so here we have multimeter on. Put the prong on. 12.61, must have a better connection than when I tried it at 11:15, because back then we were looking at 12.6. Right, we've got 12.61 at the moment. As I explained in yesterday's clip, I'm going to be running around like a blue-tailed fly trying to change the connections on the multimeter and put the fuse in and out in order to get voltage and amperage readings. I seriously thought about leaving the multimeter in circuit all the time, but yesterday I got a battery warning light on that, and I went through the hut and I haven't got a new Penlight battery that I can put in there and guarantee that the multimeter won't die in the course of the experiment. So therefore I'm going to do the blue tail fly bit and try not to get it wrong. Thus, and because I'm only going to show you the initial amperage reading when I connect it, which I'm going to do in about a minute's time, right? I'm going to try and start this experiment at 11:30. So here we are, 1 minute out. I've rejigged the multimeter to read in amps, and I've got one prong of the multimeter stuck into the fuse port. When I connect it, we should be able to get a reading on the solar panel's reaction to a battery at 12.6 volts. Okay? Alright, I'm going to leave the camera on there. I'm coming over here, and that's 11 o'clock. Right? Charging at 1.23, 1.24 amps. Not bad for a 1.7 amp panel line flat on the car in winter, is it? It's a gallium arsenide panel. They're not nearly as sensitive as a silicon panel is to the direction of the sunlight or even the wavelength. They work pretty good under a cloud. Right, now I'm going to pause the camera and I'm going to stick that fuse into this port, and I'm going to rejig the wires and find out what the volts are. Okay? Pausing now. Rejig for volts. See what's happening there? The regulator is moderating the charge to keep the voltage from going too high. Right? We're on what I call flicker float. That means the battery's a bit tender. It can't take a full 1.24 amps, even though the time is only 2 minutes after we started. So let's go and have a look at the regulator, see what it says. It says I'm charging, I'm fully charged. 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 But I don't know whether you can see it when it's claiming to be fully charged. The charging light has still got a very tiny amount of current going through it. Okay, so we're going up to 14.1 and we're coming down to 13.4. One, 1002, 1003, 1002, 1003, 1004, 1005. Okay, so it's taken 3 seconds for the voltage to drop from 14.1 to 13.4, and it's taken 4 seconds to go back up. Okay, so let's find out what the multimeter says is going in terms of amps. 1, 1000, 2, 1000, 3, 1000, 1. See what I'm... That's what you're up against. To calculate how many amp hours it's going to take to kiss and make up to the battery, you have to keep running out here every 5 minutes and measuring the relative on time and off time with the charge. And I really can't do that because I've only got a multimeter and I can't get simultaneous readings. But for a year I used to come out here at sparrow fart, half an hour before dawn. That negative, that was the amount of current being drawn from the battery to run the circuit in the solar charger. You don't get a free lunch. The solar charger itself eats power all night. So anyway, I used to work out what I call the lift-off charge, which was how many amp, or how much of an amp it would take to cause the battery voltage to rise in the morning with the low-angle sunlight. And then I'd work out what I call the lift-off charge, the trigger charge, which is when the regulator first tripped. And then I'd laboriously work my way through this flicker float on-off business until the charging light stayed on for more than 2 minutes. When the charge light stays on for more than 2 minutes and there's no current going into the battery, that's when I would declare that the battery was arbitrarily full for the day. Okay? So, as you can see, 1, 1000, 2, 1000, 3, 1004, 1, 1000, 2, 1000, 3, 1004, 1005, 1006, 1000, 7, 1000, 8, 1000, 9, 1000, 10, 1000, 11, 1000, 12, 1000. Okay, so we're running 4 to 12. Alright, so for 4 seconds you got current, 12 seconds you haven't got current. Let's see what the voltage is. See, as the battery gets more full, we come further down the scale before the regulator decides to kick in. Alright. I reckon this is pretty boring. You get the idea. By sundown, the battery will be fully charged. And I reckon we will have made up our 5 to 7 amp hours. And that for me is a fairly frantic 7 or 8 minutes. So I'll write those figures down and make another movie later on in the day and tell you what happened. But I don't know why people seem to think that you can't take a valid, scientifically accurate observation on the pension. You know, there's a bloke called James Lovelock. He invented a thing called the Gaia principle, or the Gaia hypothesis. And he stated firmly and categorically in front of the BBC, and it went worldwide, that you don't need huge corporate funding or giant government resources to do world-class research. He said you should be able to do world-class research in a garden shed on a social security payment. And I heard him saying that, 10 years ago or so, and I stopped worrying about the fact that I haven't got a big fat shiny laboratory and 500 people running around saying, yes sir, no sir, 3 bags full sir, what do you want me to do sir? All I have to do is stick by the scientific method of problem solving. Alright? A curious person makes an observation. They form an hypothesis to attempt to explain the observation. If the hypothesis is capable of making a prediction, they design an experiment to test the prediction. They observe the results of the experiment, they evaluate it and redesign a new experiment to refine the hypothesis. Right? The hypothesis becomes a theory when it's capable of making a prediction. If the predictions are experimented on and it's 100% accurate, then your theory graduates to become a law, like Betz's law of how much power you can get out of a windmill. It's like Newton's law of gravity. Betz's law is unarguable, right? Well, maybe I'm coming up with Wharton's law of SunFoils, or I'm trying to. I'm doing my best. I've got limited resources. My data logger is a pen and paper. My fuel flow meter is in the Bowser at the service station. The CSIRO don't have data loggers and fuel flow meters capable of observing a motor car. That's what they told me. And I said, well, you know, I know a bloke who has 4 certified fuel flow meters, and he keeps them bolted to a sheet of concrete and he rents them out to people. And surprised them, just that angle on how to get the information. But I think of the scientific process of problem solving, scientific method of problem solving, I think of it as the nursing process, as it was taught to me in the early 1980s. Assess, plan, implement, evaluate. I have applied the nursing process to the fact that my battery didn't get enough current from the alternator to charge it up enough to run the electric windows, even though I live 15 kilometres from town, so I put a solar panel on the car. Not only did the windows work, the car had more torque and used less fuel. So I put a bigger solar panel on my son's car and I measured that as well as I could using him as the fuel log. Once I put an even bigger solar panel on my car, I went to town, logged every engine start and shut down, got up every morning and found out how much current was going into the battery, scratched my head, and the only place I can think of for where the saving is in that drive belt. Now, Hatoma, if I've heard you suggest that if the belt was losing that much power, it would be melting. Now, do you see these flats and grooves on the outside of the belt? They're not like the ones on the, and this belt doesn't have any on the inside. Right? I don't know whether you can see that. Yeah, there's no flats and grooves on the inside. The belt is not on upside down. The purpose of those is they're cooling fins, mate. It generates more turbulent airflow around the belt, so there's more air in contact with the belt and you've got a higher contact area. Cooling fins on a fan belt to dump the excess heat. See that? I can deflect my belt a little bit. I was talking to a bloke yesterday, that day before yesterday, when he saw me with the bonnet up in the main street of Glen Innes checking the battery voltage. He's a farmer, he lives along the same Dundee area, and he come up to find out what I was doing. I explained it, and then he played with me belt and he asked my opinion on how come the mechanics stick a crowbar between his engine block and his alternator and they swing off that to try and tighten the 2 fan belts that he's got running his alternator, 120 amp alternator, might be 150 amp, in his Toyota Land Cruiser. And I said, well, they have to do that because when you start your engine, your glow plugs are on and you're putting about 120 amp, 110 amp or so load on the alternator as soon as the engine starts with a flat battery from having sat there after running the starter motor. I said, your alternator runs at nearly full output for at least 90 seconds after startup. And if you don't have 2 belts with a huge amount of stress and strain on them, it will squeal and scream and, you know, the belts are going to slip. So there's a huge amount of power being dealt with by those belts. You know? I mean, my little belt there, it's only got to deal with 8 horsepower going into it. And it's got cooling fins on it to dump the extra heat. Well, we've got an extra minute of upload time, so let's see what the multimeter says before I end the movie.